In this next video, we're going to review the role of random sampling and talk about its relationship with probability. So the concept of random sampling is something that we've talked about previously, but now it comes into play when we're talking about probabilities. So just to review, control in an experimental design is something that we use to establish cause and effect. We do this through the use of groups. We have a control group and we have an experimental group, and we use something called random sampling. So the experimental group receives the independent variable. The control group does not receive the independent variable. And the purpose of random sampling is to reduce any bias we have between these two groups, the experimental group and the control group. I want to make sure that I haven't accidentally stacked the deck such that one group is really different than the other group. I want them to be as randomly selected as possible to flesh out any sort of systematic bias. So random sampling is a necessary element for our definition of probability. There are two requirements for random sampling. Every individual in the population needs to have an equal chance of being selected, and the probabilities need to stay constant. They're sampling with replacement. So if I take a sample, I have to throw that same number of people back into the mix in order to keep my probabilities constant. We're going to demonstrate what this looks like. So assume that we have a probability of selecting one large blue marble is 5 out of 25. If I select one large red marble, the n must still be 25 for the probability to remain the same. So I would need a replacement to keep my total n at 25. So if I take one marble away, then my n becomes 24, and that changes the probabilities. So we need to do what's called sampling with replacement. We keep the n the same. So let's illustrate this. I'm going to have you actually pause the computer and figure these out, and then we're going to come back together and talk about them. We're going to use the following information to answer the next 6 questions. Let's say we have a jar of 150 jelly beans. It has 22 red jelly beans, 38 yellow jelly beans, 20 green, 28 purple, 26 blue, and the rest are orange jelly beans. Find the probability of selecting a blue jelly bean, a green jelly bean, a purple, red, and orange. And remember that you have to have sampling with replacement. So pause the video and then come on back. I'm just going to walk you through 2 of the probabilities for blue jelly beans and green jelly beans. So our directions said that we had 26 blue jelly beans and we had a total of 150 jelly beans altogether. So if I take 150 and I divide into 26, I end up with 0.1733 for my probability. My probability equals that. Or I could say 17.33% chance of drawing a blue jelly bean. Now, when I'm getting ready to draw the green jelly beans, I have to take these blue jelly beans and throw them back into the mix. I need to keep my probability denominator at 150. And so green, we had 20 green jelly beans divided by 150, which gives me a probability of 0.1333, or a 13.33% chance of drawing a green jelly bean from the total. So here are the rest of the answers, and hopefully what you did is with each and every color you figured out how many colored jelly beans are in the total, and then you divided that number by the total to get your probability. Now the orange jelly bean was a little bit harder because you were not given a number, but you were told the rest were orange. So you had to take 150, subtract A through D, those colors, and then the rest was orange. Hopefully that made sense. All right, I'll see you at the next video where we're going to be talking about frequency distributions and probabilities.